All right, so for today's lesson, we are going to look into parallel and perpendicular lines. So lines that do not intersect each other are called parallel to each other. So here in this diagram, we have 4 lines drawn, and we're being asked to identify which 2 lines are parallel. So I like to think of parallel lines as railroad tracks. So your railroad tracks will never cross each other, touch each other, or your trains would wreck. So these 2, maybe, what is happening? Oh, there it is. These 2 lines right here are parallel lines. So those continue on forever and ever, but they will never touch each other or intersect. So parallel lines run precisely in the same direction. So here, again, asking you to identify which lines are parallel. So take a second and circle the lines you think are parallel. Again, parallel lines will never intersect with each other. So these 3 lines right here are parallel to each other. We could extend all 3 of them forever in any direction according to their arrows, and they would never intersect each other. So the next slide, we're going to write that line AB is parallel to line CD. So when I write the AB is parallel to CD, I'm going to write that line AB, so we're going to write AB, we're going to put our line symbol above it. So that's line AB. When we write this 2 lines are parallel to each other, we use just 2 little straight lines. So like many parallel lines, but we don't have to put arrows on both ends in this case. Nope, they'll always just be 2 little line segments, I guess. And then we're going to put CD. And again, CD is a line, so we're putting the line symbol above it. So the symbol for parallel is just these 2 little lines, segments, I guess, technically. But that's your symbol for parallel. So your turn. See if you can write a statement that says these 2 lines are parallel to each other. So I wrote that GF is parallel to EH. You could have said that line HE is parallel to line FG. So you can switch the letters as long as F and G go together, E and H go together. And again, it wouldn't matter what order you wrote them in. If you had E and H first and then G and F second, that would be okay. The next one, I'm telling you the line AB is parallel to line CD, and line CD is parallel to line EF. And then if I tell you if all 3 lines are distinct, which means they're all 3 different lines, then is line AB parallel to line EF? What do you think? So if AB, let's draw ourselves a picture. So we're going to have AB. So here's line AB. I'm going to make line AB parallel to line CD. And then I know that CD is parallel to EF. So I have to draw EF. Oops. So since AB is parallel to CD, when you have diagrams with lines like this, a lot of times they put like this little arrow right here that says these are parallel to each other. But if CD is also parallel to EF, all three lines would have to be parallel to each other, which means AB is parallel to EF. So yes, AB would be parallel to EF. So parallel lines have the same slope. So parallel lines have the same slope. That means if they're increasing at the same rate. And then perpendicular lines cross and form 90-degree angles. We'll talk about that in a minute. Those have opposite reciprocals. And then we're going to practice finding opposite reciprocals or negative reciprocals sometimes. Those parallel lines, if they have the same slope, I just have to copy down the same number. If it's perpendicular, I have to take the opposite, and then the reciprocal, which just means we're going to flip our fraction. So if we look at this one right here, I have the fraction 3/4. If I want the opposite, I'm going to make it negative. And then to find the reciprocal, I'm going to flip the fraction. So the numerator becomes the denominator becomes the numerator. So the opposite reciprocal of 3/4 is negative 4/3. So we're flipping the fraction upside down and we're changing the sign. For this question here, it's a little bit trickier because we don't have a fraction. So first thing I want you to do is make it a fraction. So 2 divided by 1 is 2. So we just made 2 into a fraction. And then we're going to flip it, change the sign. So negative 1 over 2 would be my negative reciprocal of 2 over 1. So we flipped our fraction, went from positive to negative. For the next one, we're going to make it again a fraction, so we're going to go 1 over 1. If we flip it, it's still 1 over 1, but now it's going to be negative. So negative 1 would be the negative reciprocal of positive 1. Question number 3, or number 4, I guess. If I make 0 a fraction, 0 divided by 1 is still 0. If I flip that and change the sign, I'm going to have negative 1 over 0. Can you divide by 0? No, you can't divide by 0, so this is actually undefined. So we say it's undefined because you can't divide by 0. That one you won't have happen in your assignment. But it's just something to be aware of. And then the last one, you have negative 7 divided by 8. If it's negative and I want the opposite, so I'm going to have a positive. And then if I flip my fraction, I had 7 over 8. Now I have 8 over 7. Questions on these? All right, so jumping back into angles. So perpendicular lines have specific relationships. So we're looking back at angles. If I had to estimate the approximate approximate measure of this angle? Anybody want to take a guess? 40? Sure. We can say it's 40 degrees. It might be 41 degrees. It might be 45 degrees. So we're just approximating. What do you think the measure of this angle is at the bottom right? 90 degrees. So anytime you have a angle that's 90 degrees, that's going to create two perpendicular lines. So anytime you have lines that intersect to form right angles, they're called perpendicular. So the left is an example of a pair of perpendicular lines. We know that they're 90-degree angles because we have this little box drawn in here for us. That's what tells us they're 90 degrees. If you had to guess, which of the pairs of lines at the right are perpendicular? The first and the last one. So this one, I would say that forms a 90-degree angle. This one does not. This one, it's just been rotated. It's just the same picture that we had on the all the way on the left. It's just been rotated a little bit, and that again forms a 90-degree angle. So again, perpendicular lines just form right angles. If we're talking about their slopes, we want the opposite reciprocal. We're going to take the slope, flip the fraction, and change the sign. So here we're going to learn how to write a statement that shows that these two lines are perpendicular. So first line, let's go with RS. The symbol for perpendicular is like an upside down capital T. So if you take a capital T and you flip it upside down, that's the symbol for perpendicular. And then the second line would just be PQ, QP. So that right there is one way to say that those two lines are perpendicular. All right, so suppose that line AB is perpendicular to line CD. That means, maybe, that these are 90-degree angles, all about that intersection up there. We also are told the line CD is perpendicular to line DE. That means all of these are also 90-degree angles. So then we're being asked, which of the following is also true? Is line AB parallel to line CD? What do you think? No. We were told in our instructions that AB was perpendicular to CD. Can't be perpendicular and parallel at the same time. Is line AB perpendicular to line DE? Nope. Is line AB parallel to line DE? Yes, it is. So line AB is also parallel to line DE. So for these, we're going to use our slopes to determine if lines AB and line CD are parallel, perpendicular, or neither. So first thing, I should have written this on there, but I didn't. To find the slope is just M, y2 minus y1 divided by x2 minus x1. You should remember doing this in Algebra 1. So we're going to pair our points together. If we have line AB, I'm going to take line AB, I'm going to label it x1, y1, x2, y2. I'm just using those 2 points because they're on the same line together. So then following my formula, your slope equals y2 minus y1. Careful, we've got a double negative in there. Divided by x2 minus x1. Again, a double negative. So my suggestion is you change those double negatives to positives. and then combine terms on the top. So 2 plus 12 now is 14. And negative 2 plus 9 is 7. 14 divided by 7 is 2. So the slope of AB is positive 2. Yes, 2 over 1 is the same. Yep. If you want to go ahead and just write it as a fraction, that's fine. So 2 over 1. Then we're going to repeat this same process to find the slope of CD. So I'm going to label x1, y1, x2, y2. And then our slope of CD is y2 minus y1 divided by x2 minus x1. Got another double negative in there to be mindful of. So when I start to simplify this, I have negative 2 minus 6, which is negative 8. And then in the denominator, negative 5 plus 1, which is negative 4. When I take negative 8 divided by negative 4, I have a negative divided by a negative, which is positive. So I just have 2. So my slope of CD is 2 over 1 or just 2. Either way you want to write it. Then I have to decide. Do these slopes tell me I have parallel lines, perpendicular lines, or neither? They're parallel. Well, we know they're parallel because they have the exact same slope. So they're the same. So we know that these two lines have to be parallel to each other. Good job.
If there are two different lines, like there's one line and then there's one line
On top of it,
would those be parallel?
they're technically yes, even though it's the same line. You can write the same line like different ways, like you can reorder things to make it look different. So sometimes that might happen, but not very often. Let's try another one. So here again, we're being asked to determine if lines A, B, and C, D are parallel, perpendicular, or neither. So we're going to start off by finding the slope of AB. X1, Y1, X2, Y2. And then the slope formula is Y2 minus Y1 divided by X2 minus X1. Again, another double negative to change to a positive. So negative 2/3. So I got negative 2/3 for the slope of AB. I'm going to go back and find the slope of CD. Oh, I messed up. Did you guys get 1/4? So when I look, I'm going to bring that down. So when I compare my two slopes, so I have negative 2/3 and I have 1/4. Are those the same numbers? No. Are they opposite reciprocals? Can I flip one and change the sign and make it the other one? No. So these are neither. Moving to the next slide, the more algebraic side, maybe. Excuse me. We're gonna use the point slope formula. So point slope formula is used when you're given a point x1, y1, and the slope of the line, which is m. So the formula. It's okay. Sorry, my iPad's being slow. Y minus y1 equals m, which is your slope, and then in parentheses, x minus x1. There are three things you're gonna have to do here. You're gonna substitute in for y1, m, and x1. And then you're just going to distribute and solve for y. Your final answer will have x and y in it. So don't let that confuse you.
So are we not doing the last problem?
Did I skip one?
Yeah. That's why when you started
Oh.
saying that we were gonna do the point slope
Whoops, I skipped one. It's okay, we'll just skip it for today. Sorry. I didn't even notice. So write an equation of a line with the given point and slope. So anytime they give you a point and a slope, automatically go into point slope form. Label your point x1, y1. Your slope is m. So my formula was y minus y1 equals m times x minus x1. So I'm going in and I'm plugging in numbers for those three highlighted things. So y minus 0 equals my slope of 2/3, and then in parentheses I have x minus x1, which is -6. Be careful with that double negative. We're turning that into a positive. Would you agree that y minus 0 is just y? Yeah, if I have y and I take away nothing, it's just y. So then I'm going to distribute. When I distribute, I'm taking 2/3 times x, which is just 2/3 x. When you distribute over here, we're taking 2/3 times 6. 6 is a fraction of 6/1, right? When you multiply fractions, you multiply straight across. So 2 times 6 is 12. 3 times 1 is 3. And then can I reduce 12/3?
Yes.
Yeah, 12 divided by 3 is just 4. So when I distribute that 2/3 times 6, it actually just becomes +4, so +4. And this right here is my answer. So that's the equation of a line that goes through the point -6, 0 and has a slope of 2/3. See if you can do the next one. So I'm giving you another point and I'm giving you the slope. Label your points, x1, y1. Label your slope, m.
There's like an imaginary one in front of that y.
Yeah. All right, so when I plug things in, I had y minus -1, which becomes a +1. My slope -3/4, and then in parentheses x minus -8. Change that minus and negative to a positive. And then your next step is to distribute the -3/4 times the x, which gives you -3/4 x, and then -3/4 times 8. So I brought that over here to the side so you can see that right there. So -3/4 times 8/1. You multiply the tops together. -3 times 8 is -24. The denominators, 4 times 1 is 4, and then that simplifies or reduces to -6. So that's how I went from that 8 to a -6. So I distributed that -3/4. The last step you need to do is get y by itself. So y is being added to 1. So we want to get rid of that 1 by subtracting it. I'm subtracting it from the left side here and the like term on the right side. So -6 minus 1 is what gave me the -7 in my final answer. So my final answer, y equals -3/4 x minus 7. All right, for the next one, we're going to write an equation of a line with these given points. So here we weren't given the slope, we were given 2 ordered pairs. When I give you 2 ordered pairs, you have to find the slope. So first thing we're gonna do is find the slope. So we did that earlier. We're gonna label our points x1, y1, x2, y2. Our formula for slope is y2 minus y1 divided by x2 minus x1. So watch out for that double negative, and then -1 minus 7 is -8. 1 plus 3 is 4, which reduces to -2. So now we know that the slope is -2, and we already have 2 points. So now we're going to go back to what we did on the last slide and calculate point slope form. I'm just going to use that first point because it's already labeled. So second, we're going to use point slope form. So y minus y1, so y minus 7 equals our slope 2, parenthesis x minus x1. Again, for these problems, you've got to watch out for those double negatives, change them all to positives. So once you plug into point slope form, your next step is distribute to get rid of those parentheses. So y minus 7 equals 2x plus 6. Plus 2 times x is 2x, and 2 times 3 is 6. For our last step, we are going to add 7 to both sides, so y equals 2x plus 13. Again, we're only adding that 7 to the 6. We don't do anything with the 2x because it's not a like term. For time's sake, we're going to skip the next one and jump to the equation parallel to. So we're going to jump to this question right here. We're going to write an equation of a line parallel to y equals -5/2 x plus 9. That passes through the point -6, 7. So there are questions like this exactly on your next test. So first thing you've got to remember, what's special about parallel lines? What did we talk about earlier? They never intersect. If they never intersect, they have the same slope. So right here's the slope of the line we were given. The only thing that matters to me is that that slope is -5/2. The x plus 9 doesn't matter anymore. So for this question, we're stealing the slope because it's parallel, and we're going to use the slope of -5/2, and then we're going to use the point -6, 7 as x1, y1. And then we're going to write our equation like we did when we started point slope form. So go to point slope form, y minus y1 equals m times x minus x1, which is 6. Not -6. I told you I was skipping it. We're going to skip it to save time. So for this one, we're going to leave our y minus 7 for the time being. And then we're going to distribute -5/2 times x is -5/2 x. Then I'm going to take -5/2 times 6/1. So -5 times 6 is -30. 2 times 1 is 2, which reduces to -15. So back to my problem, I'm going to write -15 now. So now I want to get y by itself. I'm going to add 7 to both sides. So y equals -5/2 x minus 8. And that is my final answer. Going to the next slide, again, we're writing an equation parallel to this line that passes through this point, 3, -1. But notice this equation is not written correctly. So for us to steal the slope, we've got to get y by itself. So our first step is to get y by itself. It's actually going to take us a couple steps to get there. So if we want to get y by itself, I've got to get rid of the x and I've got to get rid of the -3. First thing we've got to do is move that x. Oops. The only way I can move it is by subtracting it. So -3y equals -x plus 9. And then to get rid of that -3, the -3 does not have a symbol between it and the y. So if there's no symbol between those two, it's got to be multiplication. If I want to get rid of multiplication, my only option is to divide. When you divide, you're going to divide every single term by -3. So y equals, when I have a -x divided by a -3, that's really like me having a -1x divided by a -3. So the negatives will cancel and I'm just left with 1/3 and the x is still hanging out there. 9 divided by -3 is -3. So this is how I want my equation to be written if I'm going to look at the slope of it. So the slope's always this number right here in front of x. Again, when your equation is solved for y. If I'm looking for the slope parallel, what's the slope parallel to 1/3? Parallel means they have to be exactly the same. So I'm going to keep my slope as 1/3. And then I'm going to use this point we were given. So we're forgetting everything about what we just did. None of this stuff here matters. So we stole the slope of 1/3 because it's parallel. And then we're going back to the original. We want the point they gave us, 3, -1. So I'm going to label my point x1, y1. And then I'm plugging into point slope form. Y minus y1 equals m times x minus x1, which is 3. Be mindful of those double negatives. Again, my suggestion is that you automatically turn it to a positive. And then you're going to distribute to get rid of your parentheses. When I distribute 1/3 times -3 over 1, again, multiply straight across. -3 times 1 is -3. 3 times 1 is 3. When I simplify my fraction, -3 divided by 3 is -1. So when I distribute 1/3 times -3 gives me a value of -1. One last step to get my final answer. I've got to get y back by itself. I'm going to subtract 1 from both sides. So y equals 1/3 x minus 2. And that right there is my final answer. So that is the equation of the line that's parallel to the one we were given and passes through 3, -1. I could make you graph them to prove to me, but I'm not going to do that. I just want to see your work. All right, one last problem. So here our instructions have changed by 1 word. So all that's changed is the word perpendicular instead of the word parallel. So very similar to the last question, except when we find our slope, we're going to have to take the opposite reciprocal. We're going to flip it and change the sign. So again, we've got to get y by itself so we can find out the slope of the original line. So we're going to subtract 5x. Then we're going to divide everything by 3. So that gives us an equation, y equals -5/3 x minus 7. The only thing that matters to me is this slope right here. Nothing else matters. But I want the slope perpendicular. So I want the slope perpendicular. What's the slope perpendicular to -5/3? So I'm going to change it from a negative to a positive, and then I'm going to flip my fraction. So the original was negative, so my slope perpendicular is positive. I went from 5/3 to 3/5. So the slope perpendicular is 3/5. So I'm going to use this slope right here. And I'm going to use the point they gave me up here, and I'm going to plug into point slope form. So y minus y1. So y minus 1 equals, I'm going to use my perpendicular slope this time. So 3/5. And then x minus x1, again, be mindful of that double negative. Our next step is to get rid of our parentheses by distributing the 3/5. 3/5 times x is 3/5 x. If I take 3/5 times 5/1, that gives me 15/5, which is 3. So for the right side, I'm going to have 3/5 x plus 3. Last but not least, I need to get rid of that 1, so I'm going to add 1 to both sides. So y equals 3/5 x plus 4. And that would be my final answer.